I'd like to work through 3 basic examples of proofs, and these are exactly that. They're examples. There are many others that could be used, and just to be clear, these are not going to include things like parallel lines with transversals or anything with congruence. These are simply basic geometric proofs that have the simple fundamental properties of equality or congruence, a few of the introductory definitions, and that sort of thing. So these are not a comprehensive group of examples. It's just some introductory ones. In a proof, you're trying to provide reasons for each step along the way. It's essentially your thinking that you put down on paper. These are all the thoughts that you have in your head for coming to your conclusions, but you're writing down those reasons instead of just thinking them. In pretty much every proof, the first reason is going to be given because you're going to start out with your first statement being the given information, which is what I did here. So I'm going to put given over here as our reason. And this is not 100% of the time the case, but a good rule of thumb is that if you see a phrase in a statement in the following steps reason, that will usually be showing up. Angle 1 and angle 2 are a linear pair. Because of that, I can conclude that they must be supplementary. So here for my reason, I'm using the definition of linear pair. Well, I see another word that I can use, supplementary. Well, the definition of supplementary angles is that they will add up to 180 degrees. Well, that's what I have stated here in statement number 3. So my reason, definition of supplementary angles, and I'll abbreviate it that way. We'll actually use this thinking in example 3 in a moment, but we'll go a little further with it. Example 2, we have this given information. It's been restated here, so the reason is given. But we notice that there's a word or phrase that's being used in that statement. So from that, we're going to give that as our reason, the definition of midpoint. And everything doesn't have a diagram with it, but I do think it's helpful sometimes to draw one out. We're told that B is the midpoint of segment AC. So A and C are there. B is the midpoint here. And if it's in the middle, that means each part is exactly the same length, which is what I have written in the second statement. Well, if they're equal measures, then that means the objects themselves are congruent, and we get that because that's what the definition of congruence is all about. Now you can use these abbreviations, or you could write it out completely using fully written words and all of that if you want to, but you can abbreviate it, I think, in this case. Well, let's go to example 3, and you'll notice that it's a longer proof, but it's going to refer back to what we did in example number 1. We have a diagram given to us, and we have a proof statement we're trying to get to eventually. This information, though, it really doesn't fit as a statement, but directly from this diagram, I notice that these two angles are making this straight angle. So they are a linear pair, and that is the given information directly from there. Now there could be some debate as to how many of these steps are necessary, and could you go straight to this from the beginning? You could argue that, but everybody solves proofs with slightly different steps along the way, but if you can back it up over here in your reason column, then I think it's going to be acceptable. Well, we see, like we did in the earlier example, a phrase, linear pair, leading us to know that these two angles are supplementary. So this is definition of linear pair, just like we used in example 1. We again have a phrase, supplementary, And we're going to use that then to know that that means they add up to 180 degrees. So definition of supplementary angles. Now at this point, we now are going to take this measure here and replace it with the actual expression from the diagram. And we do that here as well. So we've replaced. Anytime you replace, that is the substitution property. Then the algebra takes over from this point to the end. 20x and 17x go together. They're on the same side. We combine those terms. You could write combine like terms here or simplify, but I think you could say substitution property again. Substitution property is a little broader in its ability to explain a step than combine like terms. So most people choose that over combine like terms. Then we add 5 to both sides. And this is then the addition property of equality that allows us to do that. And we divide both sides by 37. That's the division property of equality. Our last line or statement matches the prove statement. So therefore we've finished it. All of our steps are acceptable. We took 7 steps here as opposed to 3 on the other ones. And that's just the way proofs are. Sometimes they're going to be longer than other ones.